We're going to be talking about how to identify if two triangles are similar, and we're going to go based off this definition of similarity over here on the right. Everything we do is going to tie back to this. So, triangle ABC is similar to, that's what that little tilde symbol means. So, triangle ABC is similar to triangle DEF if AB over DE equals BC over EF equals AC over DF. Okay, for the record, this means, like we talked about last time, this representing with division is how we find the scale factor. And so this just means that all sides have been multiplied by the same scale factor. So that's just the math way to write that. And then we have our corresponding angles are congruent. So A is congruent to D, B is congruent to E, C is congruent to F. So we don't have to prove that every single one of those pieces is, like, we don't have to show every single scale factor. We don't have to show every single angle to show that the triangles are similar. We just have to have enough information. And so enough information, there are 3 similarity theorems. First is angle-angle similarity, and this just means if two sets of corresponding angles are congruent, then the triangles are similar. So notice, like, our definition says we need to have 3 angles that are similar, but even just looking at this picture of, A, B, C, D, E, F, like A and D are labeled, B and E are labeled, but C and F are not labeled. Well, if all triangles have to add to 180, and we know 2 of the angles are congruent, then it follows that the third angle has to be congruent. And so because of that, we only need to show that 2 angles are, 2 sets of corresponding angles are congruent. So the best time to use this is when no side lengths are labeled in your triangles. Basically, we're just going to determine our info about our angles. So here's what we mean. State if the triangles are similar or not, then complete the similarity statement. Well, here I see that angle L is congruent to angle D, and I have angle K is congruent to angle E, and so because I have 2 sets of corresponding angles, that's enough to say that these triangles are similar using angle-angle similarity. So we just have to complete the similarity statement, meaning we have to say that triangle LKJ is similar to triangle, that's an important symbol, use it. So LKJ started at the circle, went to the rectangle, and then went up to the unlabeled. So I'm going to do the same thing down here. D, up to E, and then over to F. There we go. Part B, I see here that I have a set of vertical angles, so I know those are congruent, but I need to have one other congruent set of congruent angles, 70 and 76, 73, ooh, that doesn't match up with any of them. So these are actually not similar. And so when we finish the similarity statement, we'll just put a little cross through that to say it's not similar, so RST, and then you can write them in whatever order you want for the other triangle. Our last example, notice none of these have had the side lengths labeled, which is why I'm leaning on angle-angle similarity. Something important here is that we have some parallel lines going on. And so I can see, first off, I have a set of vertical angles. And now parallel lines, I want you to remember the parallel line relationship that we looked at on the first day of this unit. I'm going to extend this out so we can see it a little bit better. Here's two parallel lines. Then I can extend on either side here. But because these lines are parallel, I have some alternate interior angles, which are congruent. And so because of that, I can say that these two triangles are similar. So JKL, so that started at the middle, went down to this one, and then over. So JEF, I think is what those, I need to erase that. Yeah, JEF, triangle Jeff. And something I've been forgetting to write on these is saying how I know. There we go. Okay. The next we have side angle side similarity. Basically we have, how did I phrase this other one? Two sets, all right. Two sets of sides. Have been multiplied by the same scale factor. And the angle between them is similar. Sorry, congruent. Triangles are similar. And this should be used when you have two sets of sides are labeled. Like the example right over here. So this example of MNQ NOP, I have a set of vertical angles here. And here, 5 goes to 10, 6 goes to 12. They're both being multiplied by 2. And so that's enough to show that the triangles are similar. So I can look. Here we have this 39 represents angle E, which is congruent to angle L, so that's a good start. So I can look at these sides, and if you're trying to figure out which sides match together, that's how I line them up. I look at largest to largest, smallest to smallest, because no matter if you're multiplied by the same scale factor, it's not going to change that one was bigger than the other to start with. So I can come here, and 36 would have to line up with 9, but 37 would also have to line up with 9. So since those are not the same, I already know that this is not similar. So E, F, G, L, M, N. Okay, part B. I have a set of vertical angles, which is great. So now I just have to look at the side lengths. Well, 27 is the smaller side of the top triangle, and 9 is the smaller side of the bottom triangle, and then 30 is the bigger side of the top triangle, and 10 is the bigger side of the bottom triangle. And I can see that there is a scale factor of 1/3 from top to bottom, or of 3 going from bottom to top. And so a way I could show my work on this, I can either draw the arrows and say it's times 3, or I can do 27 over 9 equals 30 over 10. 3 equals 3. So we're good there. So these triangles are similar. So triangle ABC, highlight that, ABC. So it starts in the middle, it goes down the side with the boxed number, and then over. So that's going to be triangle AVU by side, angle, side, similarity. I want you to write the word similarity because there is side, angle, side congruence, and that is not the same. Okay, our last example, notice we have two triangles. We have a big one and we have a small one, and I like to redraw them. So T, Q, R, T, U, V. Small one is 54 and 66. And then we have, if I add those side lengths together, I get 77 and, let's see, 62. And so the angle that's the same between these is going to be angle T, because T is congruent to itself. And so now I just have to line these up. I see that 77 is the bigger side, and 66 is the bigger side, and then 62 to 54. And so in my calculator, since I can't see this one just off the top of my head, I'm just going to go ahead and divide them. So I'm going to do 77 over 66, which is like 1.167. And then I'm going to do 62 over 54, which is 1.148. So these are not similar. Alright, that's side, angle, side. And now we'll get to our last one, which is side, side, side. And this just means if all sets of corresponding sides have been multiplied by the same scale factor, then the triangles are similar. So you should use this one when all side lengths of the triangles are labeled. Alright, so once again, I'm going to use longest to longest, shortest to shortest. And so my longest side of my top triangle is 42, longest of the bottom is 55. So I'm going to look at 42 divided by 55. I get about 0.764. See, my shortest side is 23, First side over here is 32, so 23 over 32. We get 0.719, and because those are different, I don't have to do the last set of sides. I already have enough information to show that these are not similar. So FGH, and we can do whichever order we want for our top triangle. CBD. Okay, and this next example, I have my big triangle, 50, 55, 70, and I have my smaller triangle, 30, 42, and then I'm going to have to do 55 minus 22 to get this piece at 33. And so now we can just line up sides. So we got 50 to 30. Which is 1.667. Now I can do 70 to 42. Hey, this one's actually the same. Looking good so far. Then we're going to look at 55 to 33. All right, these ones are in fact similar. So this one, triangle KLM, so KLM, that means I'm going to go KCD. By side, 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 similarity. So now our last page of these notes is just throwing it all together and deciding which method to use. Part A, I see that all side lengths are labeled, so that's a key indicator that I should be using side, side, side. See, my biggest side is 72, my biggest side is 27. So I'll just type that in the calculator. And keep in mind, these numbers do have to be exactly the same. Even if they're like, you know, 1 decimal point off, they would not be similar. They have to be exact. Let's see, my smallest side is 40. So I'll go 40 over 16. Sorry, technical difficulties. I get 2.5, so these are not similar. Okay, part B, I have 2 sides labeled, so this one I can look at with side angle side, and here's the angle between them as vertical angles. Let's see, my longer side is 16 to 40. I get 0.4. Then we're going to do 10 to 25. And we get the same thing. Nice. So these ones are similar by side, angle, side, similarity. And now if I'm to write my statement, let's see, DCB, which means if I follow the same pattern, it's going to be DTU. Let's look at part D next, because we did something like part C. Part D, I don't have sides labeled, so it's just going to be angle, angle. I can see these two are congruent because they're both 78. But if I was to split these up, they both have angle D here. So for example, this would be DKL. and this would be DCB. We already know that these are both 78. Well, angle D has to be congruent to itself. So there we go, I have my two angles. So DCB is going to be similar to triangle DKL. Angle similarity. And then let's just do part F, because C and E are very similar, pun fully intended. Once again, I'm looking at parallel lines, so I'm just going to extend these out. Okay, when two angles are in the same spot between the top group and the bottom group, those are corresponding angles. So I got one set there. Well, if I was to do the same thing on the other side, I also have corresponding, whoops, let's try that again. Corresponding angles here. So I am getting that these two triangles are similar. So JKL went this way, so I'll do the same for JEF. And that is how we determine similarity.